Hello, I am Toshio Iwata, director of digitalfilter.com. Today, I'll talk about 6-axis sensor fusion. That consists of accelerometers 3-axis plus gyro sensors 3-axis. Those sensors are on this board, IKS4A1. And those two sensors do their own job and compensate each other. So I'll let you know about what's happening inside those two sensors and how we handle those data. This unit works with a battery, so let's start logging into the SD card. The data from the SD card is overwritten on the movie like this. Only the yellow line, z-axis, has big values. That's due to gravity from the Earth. If I set the wrong side vertical, the y-axis becomes big value because of gravity. And if I turn it upside down, it's going to be negative values. So we can see how it's inclined with respect to the vertical line. And if I set the short side vertical, only x has value. And if I turn it upside down, it's going to be positive value. It's located having some incline. And x and z axis go like this. And the acceleration of the gravity goes like this. And let's see the data from the SD card. This is timestamps. And this column is x value. This is y values. This is g values. X values are relatively bigger values. Y is very small. G has some negative values. And let's see the data sheet of the accelerometer. This one also has gyroscope. Now I'll talk about accelerometer. This register is the output register of the acceleration. So how about the format of this register? The 16-bit word in 2's complement. And this is the control register, whose scale selection is plus minus 2G. And let's go back to the data file. Since the format was 16-bit 2's complementary, and the full range was plus minus 2G, so it's going to be like this. And what if it's 16,000? It's calculated like this. The x value is 0.97G. And the G values are all negative, and Y values are all very small, so it's calculated like this. And according to these values, the gravity is decomposed like this, and the angle is calculated like this. If I lay it on the table, the z-axis is gonna be vertical line. Now the short side is vertical. I mean, the x-axis is vertical. And now I set the wrong side vertical. Since they are angular velocity, we can integrate them to get the angles. So let's integrate this area and calculate the angle. So let's see the data from the SD card. These are gyro values, and this is timestamps, and this is x-axis, y-axis, and z-axis. And only the y-axis has big values from 4,000 to 12,000. X and G, they are small values. And let's see the data sheet. This device has gyroscope and accelerometer too. Now I'll talk about gyro. And let's see the control register. This register says the full scale selection is plus minus 250 dps. I use this one. Let's see the data again. These are gyro values, and the format is also 16-bit to the complement, so the range is like this, and the full scale was plus minus 250 dps. So what if the y-axis value is 8000? The calculation is like this. Finally we get the value. It's about 60 dps. It's almost like this. The angular velocity is about 60 and it continues 6 seconds. Therefore, the area is about 360 degrees. So let's see the movie again.